I'm Eric Hollering, software architect at Flexware Innovation. Flexware is based in Fishers, Indiana, and we have over 80 engineers solving problems for clients in a variety of industries, including a dedicated team of Ignition developers. We work side by side with our customers using best-in-class software development, automation engineering, MES, IIoT, business intelligence solutions, and more. We did this project for Avery Dennison, a global materials science company specializing in the design and manufacture of a wide variety of labeling and functional materials. To help Avery Dennison with its warehousing needs, we implemented a solution accelerator we've been evolving through various logistics projects we've since named LIFT, which stands for Logistics Integration Framework Technology. LIFT is a highly configurable Ignition-based middleware framework that helps organizations automate their logistics operations. This solution has helped integrate automated guided vehicles, or AGVs, and autonomous mobile robots, or AMRs, into existing ecosystems for various customers. It typically includes interfacing with automation and control infrastructure, inventory management systems like ERP and WMS, and other line of business applications. LIFT was just what Avery Dennison needed for the recently expanded production and warehousing capacity of its plant in Greenfield, Indiana. The project included the implementation of a new JBT AGV system that would transfer materials autonomously throughout the facility, taking new product off the line and directing it to appropriate areas of the plant and picking product needed for production and shipping. Flexware used its Ignition-based LIFT framework to create a fully integrated logistics solution and help make Avery's expansion a success. One of the core problems in logistics is coordinating movement of material from point A to point B. To solve that problem, LIFT uses the concept of missions. Some missions will have more than one step, which LIFT refers to as mission legs. For instance, this mission uses an AGV to move material from the production line to a staging area as leg 1, then prompts a human side loader operator to move the material into the warehouse as leg 2. Let's look at the AGV mission leg first. You can see that this leg is defined for the AGV role. I'll talk a bit more about roles in a minute. Mission legs have something called location assignment types that determine how locations are selected. In this case, our source location will be a static single location, which means we'll always pick at GF1 unload, which is the end of the conveyor coming off the production line. You can see that this leg type is defined as split, which means there's going to be a waypoint or decision point in the middle where the AGV will stop and get a final destination. The destination configuration is set as dynamic zone lookup, which means it's going to look for an appropriate location within the drop zone to place the inventory. In this case, our zone is the warehouse staging GF1 zone, which is a set of racks that serve as a transition between the production area and the main warehouse. The zone lookup algorithm will ensure that an available location is picked and will reserve it for the transaction. Once the inventory is dropped, the upper-level ERP system is updated with the new location through an inventory move transaction. The first leg is closed and the next leg is queued up. So now let's take a look at the second leg. The second leg is defined for the side loader operator role, and the source location is a dynamic leg lookup. The dynamic leg lookup just means that it's going to go out to the drop location of the previous leg and use that as the source location. There's an option to verify the inventory, which is checked. That's going to prompt the operator to scan the roll and make sure that it's actually moving the right inventory. The destination location is set up as a dynamic zone group lookup, which is similar to the lookup we had in the staging area. In this case, the location zone group is the entire warehouse. The algorithm for the assignment will actually take into account several storage rules. The storage rules are configurable and can be used to validate or prioritize locations for the inventory based on attributes. For instance, if you had a 36-inch roll, you would not want to put it in a 26-inch high bin. Now that we've seen how a mission is configured, let's take a look at how they manifest for the operators. Here, I'm logged in as the side loader operator, and I can see missions that are active that are relevant for me as a side loader operator. For instance, here's one to take from the warehouse to one of the slitting lines. And here's one that's inbound from a coder. I can click on these and run them, abort them, or indicate that there's no inventory in stock to satisfy the need. I can also create missions manually with the Create Mission button or drill down into details. In addition to the mission dashboards, some production lines also have HMI screens where operators can see inventory moving through the system and interact with it. For instance, here I see inventory. I can actually click on that inventory and change its status to scrap. That would cause the inventory to actually be taken to scrap instead of the warehouse. The decisions are made based on a workflow process that's configurable. Now you can see the roll is at the end of the conveyor and the PLC roll present is high. It has actually just issued a pickup order using that workflow system that has told the AGV system to come get the inventory at this location and take it to an appropriate spot based on how the workflow is configured. Since the inventory is good, it's likely going to end up in the warehouse, which means it'll go through that two-step mission that we saw a little bit ago. You can actually see the pickup order ID issued here. And down below, you can see that this mission has been assigned to AGV 8. Here you can see all the AGVs with their battery status and their ETA to their targets. In the reports section, I can see missions that have run, communication back and forth between Lyft and the AGV system, history of inventory, AGV status, and even the AGVs laid out on a map. Avery Dennison added several of these reports themselves, as well as custom HMIs for the warehouse, ship-as-is area, and several production lines, which I think really speaks to the power of Ignition as a development tool. Powered by Ignition, the final product was a unified, cohesive, end-to-end logistics solution that allowed the customer to manage complex material movement within the plant. Most importantly, the system was designed to be completely configurable, putting the power into the customer's hands to maintain and expand the solution moving forward. In fact, our Avery Dennison solution owner was able to configure additional production lines and add additional reporting screens without Flexware involvement. Since the Avery implementation, we've continued to expand the capabilities of Lyft and have started migrating it to a more modular approach using the Ignition SDK to build an extensible Lyft Ignition module that supports plug-and-play modules built specifically for the various automated vehicle and inventory systems that we come across in the market.